So we have one more video.
Okay.
Okay, Saranya,
Hey,
you can start.
yeah. Hey everybody, this is Sarnya and Venkatesh, your host for the session on chaos engineering in multi-tenant and hybrid environments. I would like to welcome our speaker, Karthik, who will be introducing himself in a while. But before that, in case you have any queries or questions, you can post them in the chat or you can join the dedicated Slack threads, the link to which we'll be sending in a while. So let's get started. Over to you, Karthik.
Thanks, Saranya and Venkatesh. Hello, everyone. I hope you're having a great session thus far, great conference thus far, some wonderful talks. My name is Karthik. I am the maintainer at the open source project Litmus Chaos and lead product architecture at Chaos Native. We'll talk about chaos engineering a little specifically in this session about how you can, what are the considerations when you're doing chaos engineering in a hybrid environment and a multi-tenant system. We'll talk about what these terms mean. They mean a lot of things to a lot of people. We'll just take a look at a couple of definitions and then probably I'll provide some food for thought. Let me share my screen and yeah, so here goes. I hope my screen is visible. All right. I hope my screen is visible. Let me get started. I think chaos engineering, we all know what it is. You've heard some great talks already. You've witnessed some great insights coming from the previous talks. I just wanted to reiterate its importance. This analogy is something that is going around of late. It's like vaccination. So we inject harm to build immunity from outages. We can all relate to this analogy in the current times that we are living in. I hope you can all appreciate the fact that vaccines are very important and chaos engineering is something like that, right? There are many considerations when you've decided that you'll start your chaos engineering practice. Who is going to do it? What are the targets? Maybe what is the environment that you're going to do your chaos experiments on? When are you going to do it as part of your software delivery life cycle? And how are you going to do it? There are a lot of decisions that you will have to make. Of course, all of these are derivatives from business requirements. You heard this wonderful talk from Raman a little while back, where he talked about the importance of business implications or the way to look at reliability from a business standpoint and then work backwards from there. And you delve into the architecture and you take a look at the individual components, and then finally you decide on these are the chaos scenarios that we want to do. And then once you've sort of decided that, all these questions come up. Is it the SREs only? Is it the testing folks, the QA engineers? Are these the DevOps folks? This DevOps is a culture, but the designation called a DevOps engineer is very much in vogue. So are the DevOps engineers going to do it? Or are these application developers doing it as part of their dev test as early as dev test? And what are the targets? What are you going to take down? What are you going to kill? Very broadly, you can categorize them as application services and infrastructure elements, but they are very porous. What you term as an application service might be part of the infrastructure, and what you term as infrastructure is probably an application service that someone is building out, someone else is building out. So these are very porous terms. And then you have the environment. Are you going to do it as part of a multi-layered reproduction setup, or are you going to do it in one common staging setup where you are mimicking production workloads, it's a shared environment, or are you really mature enough to do it in the production environment itself? So the principles of chaos states that you have to do it in production, but production chaos is it's like the nirvana of a very mature chaos engineering practice. A lot of organizations would like to practice it much earlier before doing it in production. And depending upon when you're going to do your chaos, you could be doing it as part of your agile sprints. You could be doing it as part of early integration test. You might be doing it at the deployment stage. You might be, and that also sort of defines who is the persona that is doing it. And the method that's going to carry out chaos, when we say method, what is the trigger or the flow in which chaos is embedded? Is it as part of a pipeline, or is it a standalone event like a game day? Or have you subscribed to some kind of automated chaos service that keeps doing random attacks? And then comes the nitty-gritties. What is the tooling you're going to select? How are you going to do the blast radius control? How are you going to ensure security? You don't want to get some malicious attacks in the name of chaos engineering, though that is a separate category of experimentation called security chaos. What is the observability that you're setting up? What are you expecting out of your chaos practice, say, over this release, or over a period of a few months, or over a period of a few builds sometimes? What is it that you're actually looking forward from your chaos practice? So these are the nitty-gritties. There are many considerations, out of which we'll focus on a couple of them: the what and the where that you see on the screen. The what corresponds to the hybrid in our title, and the where corresponds to the multi-tenant in the title. The points that we will express here hopefully give you some ideas on improving your chaos practice. And this is something that we deliberated upon, we thought about as we built out tooling at Chaos Native and worked on the open source witness chaos project. And it's sort of distilled wisdom from speaking to members in different community meetups and conferences about what they are looking at, what their concerns are, or what they would like to see from chaos tooling, considering that it is seeing a lot of evolution in recent times after having been bracketed as a certain way of doing something for a long time. So let's talk about the what, the hybrid infrastructure. There are a lot of icons that you see, many of which you might relate to. The common parlance for hybrid infrastructure, when someone said hybrid infrastructure, maybe a few years ago, it would mean on-premise infrastructure and public cloud infrastructure, right? That's what people meant by hybrid. Maybe they're using a combination of some infra that is in on-premise and something that is hosted publicly. And then with the advent of cloud native, the cloud native paradigm, Kubernetes is the de facto orchestration standard. The birth of containers and microservices, all of this has happened or has evolved around the same time. Now, hybrid means a lot of things to a lot of people. It can be construed very differently person to person. It could be the existing definition, on-premise and cloud. It could be Kubernetes and non-Kubernetes. You're using a mix of both of this. Maybe some services are already onboarded into Kubernetes. You have managed to re-architect your application. You containerized it. You made it as microservices. But there are some legacy portions of your application, or maybe intentionally there are some non-Kubernetized services, non-containerized services running. For example, your databases. There are people who are still preferring to run databases in a non-containerized fashion. And it could also be about, okay, I am on the cloud. I'm on cloud A, B, and C. Some part of my workloads are on AWS, some part of it in Azure, some part of it is in GCP for various reasons. And so it could also mean, okay, I am on a given cloud, but I am running my own self-managed Kubernetes. Maybe I'm using some tools like KubeADM to construct my cluster. I'm managing it by myself, or maybe you have subscribed to the managed services, the Kubernetes managed services, or the managed services provided by the cloud, with not necessarily Kubernetes, but it could be RDS, or it could be S3, or it could be Azure App Service, anything for that matter. In the backdrop of what we've just spoken, another pattern has emerged, that is Kubernetes as a global control plane, which is managing infrastructure across environments, right? You could use Kubernetes as a substrate to manage both Kubernetes as well as non-Kubernetes. And you can see there are a lot of solutions that are coming up: Google Anthos, EKS Anywhere, Tanzu, Mission Control from VMware, Azure Arc, etc. And people are using this to manage their entire infrastructure, both on their clouds and on foreign clouds or remote clouds, whatever you would like to call that. And this is prompting this particular statement. The credit goes to Janaki Ram. I just picked it of a blog. It says container runtimes are the new hypervisors, and Kubernetes is the de facto orchestration software. And this is also one of the reasons why a lot of these hyperscale cloud providers are jumping in to provide Kubernetes managed services. They're equipping it with a lot of other capabilities, resulting in these kind of control planes, the Anthos, EKS Anywhere, etc. You can see on the first diagram on the right-hand side, there are many more managed Kubernetes offerings. I've just listed a few of them. The major ones, the major clouds, there is an IBM cloud, Oracle cloud, etc., etc. But despite all this happening, there is still infrastructure that you might be hosting in your own data centers. You might have services running out of physical hardware, but be still using external storage RAID arrays, for example. So there might be a lot of mixed profile of services that you have in your organization, all working towards some common end goals. As a provider, you might be providing a service to a user which is behind the curtains, running with several components running across several platforms. So what does that mean to chaos engineering? What that means is chaos engineering platforms that you're using or chaos practices that you're setting up in your organization will have to deal with a heterogeneous set of targets, right? You could be doing something on Kubernetes, you could be doing something on physical infrastructure, you could be doing something on cloud instances. There's a host of things that you see on these ellipses on the right-hand side. And when we say chaos practice, it's not only about fault injection, being able to go and take down some of these services, but also how are you going to observe it and how are you going to do the hypothesis part of it. So chaos experimentation is a lot about hypothesizing about what will happen when a certain failure occurs. And you could be peering into your dashboards to get that data, or in case of automated runs, you might want to factor that observability data back inside your experiments and use that as a rule engine to provide you with a verdict for the experiment, whether it passed or whether it failed. You could be doing that in various ways. There are various probes, as the chaos engineering world calls it. So you would probably have to identify what is the right hypothesis and what is the right infrastructure, what is the right automation that you need. And this calls for newer chaos experiments to be made available by the chaos vendors or the open source chaos platforms. But that's not the only thing. Chaos experiments are becoming commodity. You can have libraries written up, but it's about how you're going to use them to construct meaningful scenarios. What we mean, one of the main challenges is, let's say there are X number of experiments that sort of cover 60% of the diverse targets that you have in your services as part of your infrastructure profile or service profile. Now, for the remaining 40%, you would like to build up something. And what you're going to build up should be easy to build, and it should also be brought into the same paradigm or the same constructs that you're using for the rest of the 60%. To simplify this, what I'm trying to say is that the chaos platform probably needs to be extensive, and it should allow for homogeneous methods of defining an experiment, running it, viewing results, etc., while supporting diverse business logic underneath, right? So that is probably what this hybridity means to chaos engineering, or the implication of this hybridity for chaos engineering practice and platforms and tools. right? Just to elaborate on what I just mentioned a few minutes back, we are talking about definition of chaos scenarios being standardized. So you have a common way to define this is the experiment, this is the life cycle of the experiment, this is what I'm going to do as part of a pre-check, this is what I'm going to do as part of the fault injection, this is what I would like to validate, and this is what I would want to do as part of a cleanup, this is how I would like my results seen, this is how I want to execute it, this is how I want to view the metrics or the observability. And let's say I'm hooking this up with some kind of a CI/CD platform. What are the common interfaces that I have that I can leverage to run this? So you would need the diversity in business logic for the fault itself, because you're dealing with a very hybrid infrastructure. But at the same time, you need some homogeneity in the operational aspects of the chaos experimentation, because that is going to help you scale, and that's going to help a lot of people come in and hook in easily with your with whatever infra chaos infra that you have in place, and it makes things more manageable and more easier, right? So what I have on the right hand side of the screen, I've taken the chaos native Litmus, which is the enterprise version of Litmus, as an example to show how this could be achieved. But this is true for a lot of other platforms as well, and something that all the chaos vendors and the chaos applications or infrastructure tools are aspiring towards. So we have a common method of defining an experiment. In case of chaos native Litmus, it is you containerize your business logic, and the business logic might consist of a lot of APIs that you're invoking, which are platform specific. You might be leveraging the Go SDK of AWS or Google or Azure or VMware. You might be leveraging the APIs of an observability platform like Dynatrace or Datadog, and you are constructing a scenario. Then you're testing it out as a Kubernetes job, whether you're able to run it as a Kubernetes workload. Then we make some instrumentation to ensure that it fits in with the overall flow of a Litmus. That is, you have ability to generate a chaos result from what you gleaned from running the experiment. And once you have that instrumentation, you go ahead and describe this entire scenario in a chaos experiment CR. Some of the terms that I've used here might seem abstract. Maybe you know them already from previous talks. I think Sayam had a good introduction to Litmus. I will probably show you what I mean as part of a very short demo, what these resources mean. But this is the approach that the chaos engineering world is going towards. Kubernetes is becoming the substrate or the control plane for doing chaos. So the chaos intent, the hypothesis validation, the fault intent, the hypothesis validation, all that is being represented as Kubernetes resources. And there is a child resource that is carrying out, a pod essentially that is carrying out all this business logic. And you have the metrics and results, etc., for viewing purposes, right? So this is how you homogenize it while you write your own business logic. On the bottom right, there is a very simple schematic diagram which shows you how the Litmus experiments work on different cloud providers. You have an experiment pod that is consuming some secrets that have access details, or maybe it has service accounts that are mapped to your cloud service accounts. Then you're leveraging the respective APIs to go ahead and cause some chaos. Maybe you're bringing down an app service, you're taking down an EC2 instance, or you're causing some latency between your VMs, etc. Right? So that's what I meant by this. Before I go to the demo, I have a very quick demonstration to show you how Litmus running on Kubernetes can do a failure on an EC2 instance in AWS. Before I show that, I just wanted to make you familiar with a few concepts that we just saw here in the previous slides about Litmus. So Litmus is an open source project. I'm sure you are aware of that. At the heart of the project is the Chaos CRs. And Chaos Native Litmus is an open core enterprise version that builds upon Litmus, provides some additional features. But at the heart of the entire platform are these chaos resources. The experiment is pre-built. It is essentially a fault template. You have fault templates for different kinds of faults. And then you have chaos engine, which is user defined, which is what you might spend time creating. which is going to bind an instance of a given application or a component or a service with one or more fault templates that you've already installed in your cluster. These are the chaos experiment CRs that you've already installed. The chaos engine binds a fault to an instance of your service or an infra component. And it also provides you with some constructs to define how would you do your steady state hypothesis, and what is considered as a proven hypothesis, what is considered disproved, what is considered a pass and a failure. Those details are provided here, and there is an operator that reconciles it. And chaos result is another resource which is runtime generated, and it holds details of what actually ran, what was successful, what was not, and along with some other metadata around the targets that were selected for doing chaos, etc. And all of this is embedded or packed inside of a chaos workflow, which is the unit of execution of a chaos scenario in Litmus. So chaos workflow first installs the fault template on your cluster, a desired fault template. Then it applies the chaos engine against a particular application. And then it reads the chaos result and obtains a status. The workflow status might be failed or successful depending upon what the chaos result status is. So it's basically a workflow to help you do different tasks associated with the scenario. And there is a control plane which helps you to construct these workflows and run them against certain targets. And those targets could be either Kubernetes or it could be non-Kubernetes, it could be a cloud provider, it could be physical infrastructure. And it also comes with certain metrics exporters. There's a Prometheus exporter, and there are some additional auxiliary services that help you with triggering chaos in an automated fashion based on certain events, etc. So with that, let me go and do a very quick demo. This is the chaos center. This is the web UI or the dashboard part of the control plane, where I have executed some experiments prior already. Right. So the node shutdown that you see here is actually an experiment that works against a Kubernetes, against a VM or a cloud instance, an EC2 instance. The way we structure it is, or the way we define it is very similar to the way we would define a Kubernetes experiment, where I would go kill a pod or cause some network latency in the pod network, which is what I will do also as part of another quick demo. But let me just show you, let me start the workflow and then take you through the manifest of how it looks like, right? I've just started this workflow, and you're going to see that it has two steps. Like I said, there is a step in the workflow to install the fault template and then go to the actual invocation of the fault against a VM. We have mapped the instance ID. I've provided the instance ID. You could provide instance tags, or you could provide other filters. And the pod that's running on a remote cluster is able to take down EC2 instance running in a different account, because we've created a Kubernetes secret with the access credentials. The experiment pod consumes it as a secret and then carries out the chaos. There are alternative ways to do it. You could be mapping a AWS service account. If you are running chaos center on EKS, you could be using a service account that is mapped to an IAM role, and then you can be doing operations that are permissible for that IAM role. We'll talk about this a little more when discussing the multi-tenant feature. But let me go back and show you what's happening and what's actually running on these VMs. I have a sock shop microservices application that's running on these EC2 instances. It's essentially a KubeADM cluster. I'm taking down one of the EC2 instances that's running one of the services for VMsocks. What we expect to see is the instance are going to stop state. It's going to stay there for a prescribed duration, and then it's going to come back. And our hypothesis during this time is to verify if the VMsocks application continues to stay alive, and if the performance dip that we are seeing because of the failure that we have caused, to sort of recover within a predefined time, an expected time. You could think of this roughly as translating to your MTTR, mean time to recovery. So let's say I expect the user latency to drop within a certain period of time, or the QPS to pick up again. It's gone down, as you can see, to pick up again to normal operational state, normal characteristics, maybe 200, near 200 ops per second within a specific time. And I can verify if that is so or if that is being breached. Depending on that, I can go ahead and pass or fail my experiment, right? And I'm able to do this using certain probes, what we're calling as Prometheus probes and HTTP probes. The HTTP probe to validate the availability of the website, and Prometheus probe to check for some metrics. And this is how it looks. Let me just show this to you. The chaos engine looks like this. We are going ahead and saying, this is the experiment that we want to perform, and these are the probes that we are doing. There's a Prometheus probe that looks at the endpoint of Prometheus, does a PromQL query and does some comparison. And if at all this is not met, then it has a specific timeout. It has a retry interval with a period in between. It has a couple of retries with some interval defined. And I expect that before this time runs out, my service is back to good performance. And there is an HTTP probe that is looking at the website being alive. And this is a continuous probe. And the other probe that I showed for Prometheus was an edge mode probe. This is basically, these are some lower level details, edge means I'm going to do it before and after chaos. Continuous means that I'm going to keep doing it always, because I'm okay to take a dip in performance. My expectation is only that it is going to come back up within a predefined period, but my website should be available always, even if it is slow. So that is the expectation that we've burnt in for a non-Kubernetes experiment. We are taking down an infrastructure element like an EC2 instance. But the same workflow spec or a very similar workflow spec will be available for you to run some pods on Kubernetes pods as well. That is what we meant by the homogeneity, defining an experiment and defining the methods for viewing the hypothesis, etc. So with that, let me come to the next point. Since we are short on time, I'll probably move on to the next consideration, that is the where. And here we are talking about multi-tenancy. Why is this important, and what does really multi-tenancy mean? This is not a new concept. I think when the cloud-based SaaS platforms became popular many years back, multi-tenancy was one of the major features of the architecture of those platforms. But what does it mean to chaos engine, the chaos engineering? So when we say I have a multi-tenant chaos platform, what could that mean? It could mean that it is the ability to onboard several target environments and perform chaos against it. You might have a fleet of clusters running across several hosting platforms that you are bringing on to the same control plane and managing the chaos operations for. That could be one meaning. What it could also mean that you have a group of people working on your chaos engineering practice, and there are the group of people is divided into several teams, each of whom have access to a particular cluster or a set of services, maybe if it is not Kubernetes, or maybe some platforms, and you would like to isolate it that way. And you are able to create or provision those kind of teams and allow them to work on their respective platforms, help them to run experiments, view the results, etc. But because we are dealing with Kubernetes, it could also mean that you have a very large staging environment. It is a multi-namespace cluster, each namespace mapped to a service owner or to some developers where they are doing their own testing, their own thing. And probably they also want to run chaos experiments in their own namespaces, right? Without stepping on the toes of other developers or other service owners running who want to do chaos in their own namespaces, or maybe they are doing some other kind of testing. You don't want to disrupt that, right? So you are maybe it's a shared self-service infrastructure. Think Optato Cloud, for example, You're provided your own namespaces, and you just go and do your own testing there. That could also mean multi-tenant. Does your chaos platform enable you to do that? And sometimes we just don't want the agents or the chaos business logic to run against specific namespaces. We want the entire platform to be running, including the control plane. You want it to be running within a namespace, and maybe there are several such instances. So what are the considerations in this kind of a model, right? Security is one of the biggest considerations, as you would guess. You would want the targets mapped to some users, and those users need to be authenticated via some systems you might already have in place. Maybe you're having LDAP or AD, or maybe you use a Google G Suite for authentication, or maybe you use GitHub. You need to be authenticated, and you also need to ensure that this user can be working on this target, and on this target, this user can only perform so and so operations, right? Maybe you have a same cluster, but there are multiple namespaces. You have gone ahead and created agents in all these namespaces. That's how the Litmus works. You have the control plane and the agent or execution plane. You have a namespaced agent, maybe namespace agent A, namespace B, and agent B. So you're on the same cluster, but you wouldn't want to be doing anything as agent A that disrupts agent B. So as the cluster admin, you might be providing only restricted permissions to ensure that you're not a noisy neighbor, you're not causing issues. Maybe you're not doing a node drain or a node CPU hog, which is disrupting agent B. So maybe when you're doing this kind of a configuration, you're probably giving out some specific permissions to a given user to act on certain services only, and also to do certain actions on those services only, right? And this extends to observability too. What are the logs that you can see? What are the metrics that you can gather from what component, etc. And another consideration under such circumstances is what are the resources, what are the resource limits that you're going to provide? In very large clusters with several hundreds of namespaces and chaos experiments going on in parallel in all these places, you might be looking at how are you going to restrict how much a chaos experiment can consume in terms of what it is, in terms of resources to achieve what it has to achieve, and how do you limit that? How do you measure that, and how do you limit that? That's something that you might want to be doing as well as part of your platform. And the fact that bringing in hybridity once again, the fact that you're adding several types of target environments, you're adding a lot of heterogeneous environments. Maybe you have VMware, you have Google Cloud, and then you have maybe some physical infrastructure, right? How are you going to ensure, how are you going to sort of point out or identify the points of failures and then say, okay, I think this looks good to me. These are the points of failures in this particular infrastructure. This is how my service catalog is looking, or this is how my infrastructure is connected. And therefore, I'm going to pick these components out and cause this chaos. So you could do that on paper and then come to the platform and then do your experiments. You could handcraft your workflows and run it, but it would be much easier for you to do some asset discovery to see, okay, for this platform, these are the resources and assets that I have, and this is how they are interconnected, and these are the experiments that I would like to do against the services, and then set about creating those workflows and automating them, all done through the platform. That's something that eases your job and makes it makes your life simpler and makes it much more manageable as well. So when you say multi-tenant chaos, these are some of the considerations that come in. And I'd just like to show how you could do chaos against, let's say in this case, I'll do a Kubernetes fault against a cluster on a cluster, which is not where the control plane is running. So I have a different cluster connected, and there is an agent running there, and I've named it demo agent. And I'm going to take down one of the services. I'm going to take down the catalog service by doing a black hole attack, right? And in the interest of time, I'll just go ahead and rerun that without showing you how the workflow can be constructed. That's pretty simple. You can actually see that I have, in this case, I've selected the demo agent, which is actually running on a Kubernetes cluster where the control plane is not sitting. and it's going to take down the catalog. I am going to get a semi-operational website when this the chaos becomes functional, right? When the black hole attack starts, I would not be able to load the website. We've deliberately not set this particular service up in a redundant way. There's just one replica or one instance of the catalog service running, so it's going to take things down. But this is just to illustrate how you can do chaos on a remote cluster. So this is covering one aspect of the multi-tenancy that we spoke about. It's about having different agents that are sitting on your cluster, right? Allowing you to do chaos against different platforms from a single management console, right? This is what I was trying to show. And you can see that the website is not loaded successfully. We've caused the black hole attack at this point, right? But what does all this mean? What are the takeaways from all this? I just wanted to show you or help you understand that chaos engineering tooling and the chaos engineering requirements are changing. If you are starting your practice, you are probably going to be taking in a lot of these factors into consideration, the hybridity, the multi-tenant requirements, etc. I also want to reinforce that a lot of power lies with you in terms of configuration. Despite what a tool is capable or incapable of, it's up to the practitioners to set up the right networking rules, set up the right access restrictions, set up the right resource limits, set up the observability infrastructure, hypothesize correctly, and ensure that you have a productive chaos engineering practice and your experiments actually yield something. Right? I just used the chaos native litmus here to demonstrate that, and most of what we discussed and the chaos scenarios for a lot of these targets that we spoke about is available within the Litmus Enterprise Edition. I just used that as an example, but this is true for anything that you're setting up, or even if you're writing your own chaos infrastructure as well. So with that, I'd like to stop and probably take some questions.
Thanks, Karthik. Thanks for the wonderful session. I hope our audience also enjoyed it. So as we are already past the time, I would ask you folks to move on to the Slack channel and post your questions there. And Karthik, will you be sharing the slides in the thread itself?
Yes, I will.
Yeah, sure. Thank you, everybody.
Thank you. Have a great conference.
Yeah, I'll be ending the session in a while.